boys and girls. This video is once again on equivalent fractions. Now we're going to understand what equivalent fractions are. If this apple were cut along the dotted line and you got one piece, what fraction of the apple would you have? Well, if that was cut equally and they equally cut this, what do you think we would have? If what fraction would you have? One piece out of two. Okay? And let's look at this next one. If this apple were cut along the dotted lines and you got two pieces of the fraction of the apple, what fraction of the apple would you have if you got two pieces and this is cut into 4 equal parts and you got 2? Well, I bet you could see that you're going to get the same amount. In both cases, you have 1/2 of the apple. That means that 2/4 is equal to 1/2. These two pieces would be the same as this. They're just cut, this one's just cut into more pieces here. Dividing apples is one way to look at a fraction. Another way is to use fraction graphs. So here they're showing you this represents, this piece is equal to this piece. That's what they're showing you. Okay? I'm going to move back away so we can see that. So it's showing you that if I shade in 2, it's equal if I shade in 2 out of the 4. They just divided this one into 2 parts and they divided the same piece into 4 parts. Okay? Which then gave us 1/2 is equal to 2/4. Circle the fractions below that is equivalent to 1/2 and 2/4. So, if I was looking at this first fraction, I don't want you to see it, I'm going to talk about this one right here. And we know that this is 2 pieces out of 3. Is that showing 1/2? 2 pieces out of 3. Well, to show half, it would be half of what the whole is divided into. And 2 is not half of 3. But let's look here. 1, 2, 3, 4, 5, 6. This one is cut into 6 parts and they're shading 3. Is half of 6 3? Yes. So then this one is equivalent to 1/2. What are equivalent fractions? Take a moment and pause the video and come up with some ideas. And when I come back to you, I will have some ideas written up here as well and we can share through them. Here are a few things that we kind of talked about. They show equal parts. And so in other words, they show the same whole in the same part. They're all equally divided up. I don't have that up there, but I do have equal parts. All the pieces are equal and it shows the same amount. They name the same amount, they just are written differently. So even though 5/10 is a fraction that shows is the same as 1/2, think of if I had a cake in 10 parts and I have 5 of the pieces. I have 5/2 of it. Even though they show the same amount, they're just written with different numbers here, but they mean the same thing. So those are just some of the few, and I would love to see all of your ideas. Text them, post them to me, put them on Canvas, on your paper, anything extra that you came up with, that what you thought about equivalent fractions and what they were. Do the circles here show equivalent fractions? Why or why not? Okay, what fraction of the circle is shaded A? Okay, are the pieces equal? And it's put into 2 equal parts. So what we do is you look at the shaded part and how many pieces make the whole. What fraction of circle B is shaded in? 1, 2, 3, 4, 5, 6, 7, 8. It's in 8 equal parts. 4. Now let's go back. Do these show equivalent fractions? Is this equivalent to this? Well, think about it. If it was the same circle, This one is just cut up twice, but if I came back in here and I decided to cut it up, and if I did it perfectly, could I still get, is the same amount shaded if I cut it into eighths? Exactly right. So those are equivalent. Okay. Do the rectangles here show equivalent fractions? Why or why not? Well, let's answer these questions. What fraction of rectangle A is shaded? So how much is shaded? 2 pieces out of 3. What fraction is shaded? 2/3. Well, let's look here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 pieces. And 6 of them are shaded in. Okay? Do they show equivalency? Well, if I was to lay this on top, or wait, if I was to divide this long piece into equal parts, would I get the same? Could I show that? Yes, I can. So, yes, they are equivalent. Because the same amount is shaded, it's just that this one is not divided up as much as this one is, but they're divided into equal parts. Okay? I'm not sure why this is keep coming up, but do the rectangles here show equivalent fractions? Why or why not? So let's answer this. This is 2 pieces out of 6. So this fraction is 2/6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 2 pieces are shaded out of 10. Do these rectangles show equivalency? Is A equal to B? Think about that for a minute. Okay, the answer is no. If you look at this, are these rectangles the same? Is the whole the same? Are they the same size? So since my whole is not the same, then my pieces are not going to be the same when I divide it. So we can't prove that it is equivalent. And notice here, if I was to lay this on top of here, these may not match up with that. It may come a little close, but they're going to come over a little. Because this, I cannot put this into 5 equal parts where it would look like this. Well, 10, 6 and 6. So can I divide this into, equal parts? No. So then therefore they are not equivalent. Okay. To find equivalent fractions, multiply the numerator and the denominator by the same non-zero number. Non-zero just means any number except for 0. So here are the examples. 3/5, if we multiply this by the numerator and the denominator by the same number, we can come out with an equivalent fraction. So here is 3/5. If we multiply the top and the bottom, and we like to multiply by 2 because 2's are a small number. 1's just going to give us the same fraction because anything we multiply by 1 is 1. So we start out with 2. Usually we're doing equivalent fractions. And we multiply the top number, so that's where they took 3 times 2 and got 6, and the bottom number and got 10. So then out to the side, you see that 3/5 is equal to 6/10. 3/5 times 4/4 is 3 times 4 is 12, and 5 times 4 is 20. So they multiply the top and the bottom by 4. The same number, and it can be any number, but it has to be the same, the numerator and denominator. And here 3/5 is equal to 12/20. Okay. So let's generate some equivalent fractions. Find equivalent fractions for the following fractions by using 3 as a multiplier. So here they're wanting us to multiply the numerator and denominator by 3. And I teach my students this little chant. I say, how do you find equivalent fractions? And they break out, multiply, divide. Multiply, divide by the same number, top and bottom. This is how we do it. Top meaning the numerator, bottom meaning the denominator, okay? So we're going to do it by 3. multiply top and bottom, and we get 12, and 5 times 3 is 15. So therefore we know that 4/5 is the same as 12/15. Multiply this one by 3, and notice we're going to get 7 times 3 is 21, and 8 times 3 is 24. So 7/8 is equal to 21/24. Finish this page on your own. Okay, coming back, hopefully you got 3/6 and 9/18, and you got 6/9 and 18/27. Those are equivalent fractions there. Okay, how could you make 2/3 equivalent to a fraction with a denominator of 12? Well, look at the fraction they have here. They have 2/3 is equal to blank over 12. Remember, what you do to the bottom, you have to do to the top. So look, how are they getting 3 to turn into 12? Ah, you got it. Times 4. What you do to the bottom, you do to the top. So let's see if we got that right. Okay. It says, what was 3 multiplied by to get 12? Whatever you do to the top, you must do to the bottom. So here's that example here. So you can pause this video, really look at it, think about what it's saying here. Same type of question here. But look, my unknown is at the bottom, but it doesn't matter where it's at. But we do have to go from what we know to what we don't know. And what we don't know is this box right here. So when we're going from a big number to a small number. And I hope you remember from input and output charts and doing our tables there that when we're going from something big to something small, we are subtracting or we are dividing. So here we're going to either subtract 3, but we don't subtract when we're finding equivalent fractions. We either multiply, divide. Multiply, divide. That's that chant again, by the same number, top and bottom. So we're going to divide that by 2 to get 3. Then when I do the top, we do to the bottom. So 10 divided by 2 is 5. Pause this video and do this one on your own. Notice they're putting the box in different spots. So right here, I have to go from what I know to what I don't know. And I times this by 4. Ooh, that's kind of opposite, isn't it? Okay. So go back through this video. I hope you enjoyed equivalent fractions. They're one of my favorites. Think about that chant and practice generating those equivalent fractions.